Okay, thanks for coming. Hello, everyone. My name is Yangfan Zhong, and from Alibaba Infrastructure Service Department in China. I'd like to share with you about a large-scale deployment experience use immersion cooling in data center. With the improvement of computing performance, the power consumption is significantly increased. Increasing power consumption of several components brings enormous challenges to heat dissipation and power optimization. Immersion cooling completely breaking the air cooling power dissipation bottleneck and also achieve extremely low PUE. This presentation introduces this problem encountered by Alibaba in the scale deployment of immersion cooling data center solutions and considerations. The following share is divided into 4 parts. There are today's data center challenges. Why immersion cooling? Challenges of immersion cooling. Practice of Alibaba. Let's take a look at the rack power density trend, as can be seen from the left picture. Rack power density is growing rapidly in recent years. It is estimated that the max power density per rack will reach 40 kilowatts by 2020. I think it's more conservative. The right picture shows that the air cooling cannot meet the heat dissipation demand under a stable cost when the power density is more than 30 kilowatts per rack. So, obviously, the data center needs new summer approaches. As can be seen from the left picture, the uptime in studios server reports a wide range of PUE is 1.8 more or less. Only 6% of the respondents claim a PUE less than 1.3. Not any company can build data center in the last article. The right picture shows that about 33% power is used for cooling in a traditional air cooling data center. We all know the formula how to calculate the PUE, how to achieve low PUE and optimize the TCO. That has become a new challenge. Next is the second part, why immersion cooling. Firstly, let's review how immersion cooling works. The IT equipment, as can be seen from the left picture, the IT equipment is directly immersed in the non-conductive liquid. The liquid absorbs the heat generated The liquid absorbs the heat generated by the IT equipment, and the liquid absorbs the heat generated by the IT equipment, the heat transferred to the water in the heat exchanger through the inlet flow loop, and then the heat is transferred to the outdoor cooling tower through the water loop and distributed to the air. So the immersion cooling doesn't, as can be seen in this picture, the immersion cooling doesn't need air conditioners, fans, and other things. So immersion cooling data center is very simple. Less power by using liquid that has greater heat transfer capacity. On the premise of stable cost, the air cooling can only hold about 25 to 30 kilowatts per rack heat dissipation. The immersion cooling can hold about 100 kilowatts per tank, increased by 300%. Next is the third part, challenges of immersion cooling. Immersion cooling is not new technology, but it is not popular in the data center deploy. I think the first reason is that air cooling can cover large parts series now, but the future high density is coming. The second reason is that it has a lot of challenges. Alibaba has more than 3 years research in this project, including materials compatibility, tank design, liquid cooling control, and the monitoring system. It's really a big project, not only about IT infrastructure. Next, it's mainly divided into 3 categories to introduce: server level, component level, and basic level. The basic level, I think, contains liquid selection, material compatibility, signal integrity. Firstly, choosing the right heat transfer flow for immersion cooling requires a multi-faceted evaluation of flow in candidates. The chart shows below the different parameters. Firstly, all flows are considered non-toxic and non-hazardous. The flows were compared along parameters of heat transfer, electronic insult, chemical stability, material compatibility, and oxidation stability, flammability, and cost. Then compression shows that fluorocarbon flows are efficient, safe solutions to immersion cooling. The Mallory and the white oils are often considered for use as heat transfer flows for immersion cooling of bit miners and inertics due to its low cost and dielectric properties. Unfortunately, most potential and current users of Mallory oil are unaware of the cross effects of many naturally occurring sulfur components that exist in Mallory and white oils. In this post, I want to highlight the corrosive sulfur problem and the impacts it can have on your service. About material compatibility, liquid should be compatible with all the materials, all kinds of chemicals elements, including all kinds of meter materials, different plastic cables, connectors, anything. Beyond being an effective cooling medium, an electric cooling fluid must not affect the physical characteristics of the other components of the cooling system. Together with our suppliers, we test the compatibility of materials in service with liquids. We found that there are some risks in individual devices and materials. As can be seen from this picture, we found that this is the type of relay in liquids we found which increase. This is because of its porosity, liquids into the device. So the solutions we must replace the relay with good sealing. Some materials like this noble cover in liquid, we found which decrease because of PVC dissolvers in the liquid. So these solutions, we must replace PVC with PTFE of other materials. About the signal integrity. For compression, below air's dielectric constant is 1. Different liquids have different electric constants. So all the high-speed signals should be tested. Together with our suppliers, we found that liquids with dielectric constant less than 2 can basically satisfy the signal compatibility of existing servers. But with the improvement of server performance, we know the singular frequency becomes higher and higher. So it is a requirement that high-speed signals are wired in middle layer in this server. About the component level contents, it mainly validates the performance and compatibility of CPU, storage, memory, network, etc. in liquid. There's no doubt that all the performance stability, energy efficiency in liquid. To confirm if there is an issue or degradation on TQL for helium HDD fully immersed in the liquid, we designed a test fixture. It can control the temperature we set at 55 degrees C. The liquid surface is about 85 centimeters high. After a long time stress test, we found no fatal issue and degradation were observed. So the helium HDD is compatible with a liquid. It can work well. Especially, we always know that the light is refractive in liquid. So as can be seen from the left picture, we used this type of optical model in the early testing phase, but we found it cannot work in liquid. So we have to find all kinds of optical model in the liquid. As can be seen from the light picture, this type of optical device is sealed well. This type of optical model is work in the liquid. So we selected this type of optical model in the large scale deployment. This optical model is performed. For the system level, it includes several architecture, design, tank design, and data center cabling, liquid cooling pipe layout design, system temperature, and liquid capacity monitoring and alarm system design. It's really complicated stuff. It's really hard to fully cover in advance. About the tank design, we have designed two kinds of tanks. As can be seen from this picture, this kind of tank is unsealed. The cable is not sealed. As can be seen from the right picture, this tank is sealed. The cable is sealed. Through long-time operation test, we found that the difference of liquid loss between the two tanks is quite large. In order to reduce the operation cost, finally, we chose the sealed design tank. The annual flow loss is about 1%. Another big challenge is maintenance. We all know high-density JBOD storage just like this. As can be seen from this picture, we have designed a mobile robot arm to assist the equipment to move up and down. When maintaining the server, you just need to control this robot move near to the tank. Robots can up and down. Robots are so efficient that one person can handle them, but in traditional air conditioning, that is not impossible. Maintenance is no longer a problem. As can be seen from this picture, there are 54 units in one tank. We designed 6 units for switches, about 48 units for servers. Support switch 1 pulse, 1 redundancy. Each switch has 48 ports totally. There are the special maintenance needed. Next is the fourth part, practice of Alibaba. To reduce energy consumption and achieve environmental protection, Alibaba redesigned the data center architectures, creatively bring the immersion cooling solution to its current data centers, as can be seen from this picture. We built out the world's first immersion cooling server cluster in Internet industry 2017. Then in 2018, large-scale deployment was achieved at the Beijing Winter Olympics Cloud Data Center in Zhangbei County. The commercial production of immersion cooling was officially started. Alibaba completed redesigned servers, storage, and network architectures for immersion cooling. All IT equipment in a data center, so you don't need air conditioner and fans, and in other sense, all IT equipment are in a data center are wholly immersed into the cooling flows without installation and cross-service. The heat is high efficiently transmitted to the outside through cooling system. The low efficiency traditional fans and air conditioner are no longer used. It brings the air cooling, power dissipation, bottleneck, and also achieve extremely low POE 1.7. This is totally POE. For example, in the China South high temperature, the environment, air cooling POE is 1.5. The immersion cooling can be 1.07. Considering that there are no fans in servers, totally we calculated about 36% power can be saved. The immersion cooling technology is not restricted by geographic and environmental restrictions. No POE in any climate zone. At present, the air cooling technology is widely used in electrical equipment. Is complex and diverse environment is difficult to avoid in the use of electric products. The diversity of the environment includes temperature, humidity, vibration, and dust, and so on. The IT device is completely immersed in a dielectric fluid, and thus completely isolated from the air. Liquid protects IT device from harsh environment. Immersion cooling compared with air cooling. Limitation, humidity, vibration, dust on the physical factors of electric equipment. Through nearly a year of large-scale operation, we found that the failure rate of storage HDD in liquids is about 50% lower than that of air cooling data center. So the immersion cooling can help the IT devices get higher reliability. About the higher stability, the thermal capacity of liquid is higher than the thermal capacity of the air, about 1,000 times. So thermal interiority of a liquid base 1,000 times higher than air. Liquid can safely absorb the heat pulse during heat exchanger units are in trouble. So this is very stable for the IT equipment. If doesn't meet some troubles, the IT equipment can support more and more. As can be seen from this picture, when all fans stop, servers with air cooling can support about 5 seconds. But in the immersion cooling data center, the servers can support about 30 minutes when all bombs stop. Let's compare the noise in the data center. In Alibaba air cooling data centers, noise levels reach about up to 95 dB because there are low air conditions fans in the immersion cooling data center. So the noise in the room was greatly reduced. In immersion cooling data center, noise levels are about 50 dB. So finally, summary. The word immersion cooling is a better way to take the high power density challenges. The world's first immersion cooling data center in internet industry built by Alibaba is bringing a disruptive energy-saving data centers revolution, which serves the challenges of post-war era. We hope to work together with industry partners to promote ecological development. And next, we will show you a video. Okay, that's all. Any questions? Thanks. Okay, how many servers? We can show. As can be seen from this picture, we have 48 units for servers. We can support 48 servers in one tank. In our immersion cooling data center, about 60 tanks in one room. So you can calculate about 2,000 servers in our data center. Because of the servers, we use the same as the air cooling servers. So the max power of consumption per server is about 500 to 600 watt. Okay.
You are effectively generating a lot of heat in water, warm water. Are you making any efforts towards reusing that heat?
Do you mean water?
Yeah, you are creating warm water with your immersion system.
The temperature water is about 30 to 40 degrees C. And the temperature of the liquid is about we can 30 to 50. It depends on your IT equipment. Just like if you use the HD storage, you must control the temperature of the liquid is about 30 to 40 degrees C. You can get better reliability.
Are you looking to increase that temperature to allow
Yeah.
reusable heat?
Yeah. If you don't use HDD storage, you can improve the temperature of the liquid about 50 to 60. You can it depends on the servers of all components in your servers. Thanks. We use the helium HDD in our immersion cooling data center. The traditional HDD can't use in the liquid because of liquid can into the HDD. Okay.
What's the initial cost of comparison with the original conversion server to this immersion cooling server? The initial cost, like the installation or first cost?
Can you repeat that? Louder? Repeat it again. Oh, about the TCO, about the capacity, you can say the immersion cooling data center doesn't need the air condition and the fans and the areas of the room is very low. So every company TCO model is different. For my comparison, if the rack power density is more than 30 kilowatts per rack, you can get better TCO benefit. Thank you.
Can you describe more about the failure scenario where you mentioned that you were able to?
Yeah. You need to failure the liquid about some materials just like PVC can reserve in this liquid, you must refill and filter the liquid during the operation of the tank.